Good morning, everybody. Today's article is gradient, divergent, curl, and Laplacian operator in orthogonal curvilinear coordinate system here. Now, this word is new orthogonal here. Now, which curvilinear coordinate said to be orthogonal here? Curvilinear coordinate system is said to be orthogonal if tangent to the coordinate curve at the point of intersection are mutually perpendicular to each other, then this coordinate system is said to be orthogonal here. At the end of this chapter here, we have to solve the number of examples on this orthogonal curvilinear coordinate system here. This is lecture number 4 of TYBSc Mathematical Methods in Physics here. Today we have to take here what is gradient here. So here del psi is equal to f1 e1 plus f2 e2 plus f3 E3 here. Suppose it is equation number 1 here, where E1, E2 and E3 are the unit vector in the direction of the curve U1, U2, U3. Last time we saw that here. F1, F2, F3 that we have to calculate here. Now then we know that here, what is R bar? R is the function of U1, U2 and U3 here. Take the partial depreciation of R bar here. What we get here? We get here dr bar is equal to deva R by deva U1 plus deva R by deva U2 into du1 into du2 plus deva r by deva u3 into du3 here. So this is the partial depreciation of dr bar here, where r is the function of u1, u2, u3 here. Now next we saw here what is d psi here. D psi is equal to del psi into dr bar here. How we get here? We know that here if we multiply d psi by dr bar here, what is the equation for that here? Then you will get the same equation here. So this is the equation here. So here multiply this equation here. Then what we get here? It is del psi into dr bar here. So what we get here? It is now before that here we must know what is we have to calculate this here. What is deva r by deva u here? Now here deva r by deva u1, deva r by deva u1 mod and e1 here. What is the relation between e cap deva r by deva u1 mod here and deva r by deva bar here. Last time we saw here what is e cap here. E cap is equal to deva r by deva u1 bar upon deva r by deva u1 here. So what is deva r by deva u1? Deva r bar by deva u1 is equal to e1 multiply by this equation here. So we say that it is equal to h1 here. So deva r by deva e1 is equal to e1 is equal to e1 into h1 here. So we say that we can write here e1 h1 du1 plus deva r by deva u2. Similarly, we can write here it is here u2 e2 h2 and deva r by deva u3 can be written as e2 e3 h3 here. So it is here e2 h2 du2 plus e3 h3 du3 here. So we can see it is equation number 2 here. Now here we know that here what is d psi? D psi is equal to del psi into dr bar here. So it is equation number 3 here. Now we know this is equation number 1 and this is equation number 2. We have to take d psi from this equation number 1 and dr bar from equation number 2 here. What do we get here? We can write here what is del psi? Del psi is equal to f1 e1 plus f2 e2 plus f3 e3 and it is multiplied by dr bar. Dr bar is equal to this equation here. So it is your e1 h1 du1 plus e2 h2 du2 plus e3 h3 du3 here. Now here we know that here this first term multiplied by this second say bracketed term, all this term here, but we know that here e1 dot e1 is equal to 1. Similarly e1 dot e2 is equal to 0, e1 dot e3 is equal to 0 here. So this is the dot product here. So this term multiplied by all this bracketed term here, but other terms gets cancelled with each other here because e1 dot e2 is equal to e2, e1 dot e3 is equal to 0 here. So e1 dot e1 is equal to 1 over here. So what we get here? It is your f1 h1 du1 here. Similarly e2 dot e2 is equal to 1 here, e2 dot e1 is equal to 0 and e2 dot e3 is also equal to 0 here. So what we get in second term here? It is f2 e2 dot e2 is equal to f2 h2 du2. Similarly f3 h3 du3 here. So it is equation number 3 here. So here this is the dot product. It is similar to the IJK here. So it is your d psi here. As we know that here psi is the function of u1 u2 u3. Take the partial depreciation of this psi here. So what we get here? It is d psi is equal to deva psi by deva u1 du1 plus deva psi by deva u2 du2 plus deva psi by deva u3 du3 here. So it is equation number 4 here. So here compare this equation 3 and 4. What we get here? If the left hand side of the equation 2 and 3 and 4 are same here, so equal to right hand side here. So here this is the f1 h1 du1. This is the term here. Okay. Now here this is the second term here. This is the second term here, and this is the third term here. So here they are similar here. So we can do all this thing here. So we rewrite this equation lastly. So can we write it this way here? Deva psi by deva u1 is equal to f1 h1. Yes, we can write here. So here f1 h1 is equal to deva psi by deva u1, deva psi by deva u1. Similarly, f2 h2 is equal to deva psi by deva u2, and f3 h3 is equal to deva psi by deva u3. Last time we saw here that psi is equal to f1 e1 plus f2 e2 and f3 3 here. Last time I told you that here where f1 f2 f3 that we have to define here, determine here. So what is f1? f1 is equal to 1 upon h1 deva psi by deva u1. Similarly, what is f2? f2 is equal to 1 upon h2 deva psi by deva u2 here, and it is f3 is equal to what is f1 h3 yes, it is multiplied and it is equal to here. It is equal to here. So here what is f3? f3 is equal to 1 upon h3 deva psi by deva u3 here. So here now here these are the f1, f2, f3. These are the determined here. So here substitute this value of f1, f2, f3 in equation 1. What we get here? We get here del psi is equal to what is f1? f1 is equal to 1 upon h1 deva psi by deva u1 here. So here it is e1 is already here. So we can write here e1 upon h1 deva psi by deva u1 plus f2 e2 here. What is f2? f2 is equal to 1 upon h2 deva psi by deva u2 here. So we can write here it is e2, it is as it is here, upon h2 deva psi by deva u2 plus f3 is 1 upon h3 deva psi by deva u3 here. e3 is already here, so we can write here it is e3 upon h3 deva psi by deva u3 here. So this is the equation here. Now here this is I think it is 1, it is 2 and it is 3 here. It is 1, 2 and 3 we can write here. So here if we write here no, here is sign it is only sign here. So here if we write if psi is equal to u1 here, if psi is equal to u1, then what happens here? Del u1 is equal to, now here deva u1 by deva u1. Now here deva u1 by deva u2, this term becomes 0. Deva u1 by deva u3, depreciation of u1 with respect to u3 it is equal to 0 here. So what we get here? Deva u1 is equal to e1 upon h1 deva u1 upon deva u1. This gets cancelled with each other here. So here what we get here is e1 upon h1 here. So here del u1 is equal to e1 upon h1 here. So similarly, if psi is equal to u2 here, then what we get here? If psi is equal to u2, then here del u2 is equal to e2 upon h2 here, e2 upon h2 here. And if psi is equal to u3 here, what we get here? Del u3 is equal to e3 upon h3 here. So these are the equation of del u1, del u2 and del u3 here. But here we can write a last equation for this gradient here. If so here we know that here del psi is equal to e1 upon h1 deva psi by deva u1 plus e2 upon h2 deva psi by deva u2 plus e3 upon h3 deva psi by deva u3. So this is the equation of the gradient here. But if we write here what is del? Then del is equal to e1 upon h1 deva by deva u1 plus e2 upon h2 deva by deva u2 plus e3 upon h3 deva by deva u3. This is the equation of the gradient here. So this is the article. So this is the equation of gradient here. Thank you very much. Have a good day.